Hello, welcome to day 5, polar functions and graphs. This is going to be very similar to what we did last class. Day 4 was just polar functions. This first page is going to be basically what I did on the last page of day 4. So I'm going to write our key. And today's going to be playing with the calculator a lot. I'm going to be switching back and forth between the notes and the calculator. So the first thing I want to do is take the mode key on my calculator, which is right here. I want to switch it to polar mode. So here's my TI-84 calculator, and I want to switch the mode to polar mode. So I hit the mode key. I make sure it's in degree mode, but where it says function, I'm going to switch it to polar mode. And then I'm going to switch out of here by doing second mode, which puts it out of here. And now I'm in polar mode, and I'm going to minimize this for now. Come back to it in a second. So what happens when I press the y equals key? The y equals key is right here. Do I get y equals any longer? Well, let's see what I get. So when I'm in the calculator mode, here I am. What happens when I hit the y equals key? I don't see y equals any longer. I see r equals, because we're in polar mode and our equations are going to be r equals. So let's write this out. What happens when I do this? I get r equals something, not y equals. So what happens when I hit this variable key, which is the key underneath mode, which is right here? Well, if we go to our calculator, when I hit the mode key, or when I hit the variable key, which is the key right here, it says theta. It doesn't say x, it doesn't say anything else, it says theta. So one here. Let's change the color. When you press this key, you get theta equals, you get theta. You don't get not x. So when we're in polar mode, we have r's and we have thetas. We don't have x's and y's. R will be a function of theta, and r is the input. Theta is the input and r is the output. Which is weird because when we write ordered pairs, our points are r comma theta, and we think r should be the input and theta should be the output. Not in polar mode. Even though r comes first, it is the output. Theta is the input. Let's try an example. This is an example we did last class. R equals 8 sine of theta. I'm going to go to my calculator. I'm going to clear this out. I'm going to type in 8 sine theta. And I'm going to hit zoom 6. Zoom is at the top here. 6 is the standard zoom. And it looks kind of egg-shaped. I'm going to go back to zoom and hit number 5. And zoom 5 will square up the picture. And this is the picture I get. Yes, it is a circle. So as a recap, what I did was put 8 sine theta in the calculator, and I hit zoom 6, and then zoom 5 to square it up, and this is the picture I got. It was a circle. It is not a function. I'm going to have the table do this for me. I'm not going to calculate all the values myself. So when I want to see a table, I need to hit second window to set up the table. And when I'm done, I'm going to hit second graph, which allows me to see the table. We're going to talk about this table start and delta table on how we do things, but the table start is where I want to initiate the table at, and the delta table is my increments on when I want to do the values of the table. So I would hit the second window, which is the table setup, and it's already set at 0 and 15, and I would do second graph, and then I would see the theta values and the R values that correspond to it. So this is what happens when I hit the window key on the calculator. I'll show you in a minute, but this is what is set when I did that zoom 6, my standard window. I have this theta min, this theta max, this theta step, x min max, and all this other stuff. Some of it looks familiar from before, but this stuff here all looks new. I'm going to explain what this means. Let's see what it looks like on the calculator. So here's my table. Here's my actual graph of that circle. I hit the window. This is what I get. 0 to 360 for the theta min and max. Theta step was 7.5, and so on and so forth. What does all this mean? Well, let's see what it all means. X min and X max isn't really any different than it was before. It is the same as before. It is the dimensions for the X and Y axis. Now the big difference that we see here is this theta min and theta max. This theta min and theta max is how it draws the graph. It sets the min and max value for theta that's being used in the equation or my input. Theta step, this is a big one. Theta step is the increment of theta to graph the points. So my standard one is my theta step is 7.5. That means it's going to start at 0 degrees, and every 7.5 degrees it will draw a point. Let's talk about what happens if we play with our theta min and theta max. Our theta step. What happens to the graph? So right now I'm in my window, and my theta step is 7.5. If I change this to something like 20, that means it's going to start at 0 and draw a point every 20 degrees. Well, let's see what this graph looks like. It doesn't look as good as before. It's drawing the same graph as before, but see these points? It's at 0 degrees, 20, 40, 60, 80. It's drawing a point every 20 degrees and is connecting a straight line between those points. As opposed to if I set theta step to something smaller like 2, it drew much more of a circle. So the idea is that the smaller theta step is going to do more points, which is a smoother graph, and the larger theta step is going to do less points and it's going to be a more jagged graph. Okay, I'm going to complete this table by using the table feature on my calculator. Again, I'm using R equals 8 sine of theta as my equation. I'm going to round all numbers to 1 decimal. I'm also going to I'm going to draw it on the calculator, but I'm going to slow it down a little bit. So a way I could slow it down is when I go to my y equals, I say R equals, I move the cursor to the left, and I hit enter here, see it says color is blue. I'm going to keep it blue, and then it says line. Right now it's drawing a solid line. When I could change this, I could change it to a thin line, thicker line. When I choose this one, this little like dash 0, that means it's going to draw the graph as a solid line, but you're going to see the little tracer head at the beginning of the graph. That's a little circle that you're going to see at the beginning of the graph. I'm going to hit OK for this. See, so now when I hit graph, it's drawing the graph with a tracer on it. Not is it only drawing the graph, it's drawing it slower. And you're seeing that this graph is actually being drawn twice. It is a circle. It is being drawn from 0 to 360 degrees, but it's being drawn twice. So how can I calculate all these values for this table? Again, I go to second window in my table setup. I do want 0 through 15. 0 is my table start, 15 is my delta table, my increments for my thetas. And I could go to second graph, and I can see all these values here. Okay, I'm going to put this all into my table, and then I'm actually going to graph all these numbers. As you can see, I use my graphing calculator to complete the table, and now I'm going to graph some of the points. And remember, I'm graphing r theta, so the first one is going to be at angle 0, radius of 0, which is just the origin. Right here in the middle. At 15 degrees, I'm going to go out 2.1. So 15 degrees, I'm going to go out 1, 2, 2.1. At 30 degrees, I'm going to go out 4, 3, 4. At 45 degrees, I'm going to go out 5.7, 5.7. At 60 degrees, I'm going to go out 6.9. 6.9. 75 degrees, I'm going to go 7.7. And at 90 degrees, I'm going to go out 8. Okay, I'm going to pause the recording and do the rest of the points. Okay, so I've drawn all the points from 0 through 180 degrees. I'm going to draw the points starting with 195 degrees. So it's going to be 195 degrees, but it's going to be, instead of being over here, that would be positive 2.1. I need negative 2.1, which is, again, right here at the first point that I drew. So if you notice, what's going to happen is, every point I already drew from 0 to 180, I'm going to draw again. This is where I get this picture like this. And that would be 0 through 180, and then what's happening, it's drawing it again. That's why when we saw it on the calculator, it drew a circle, but it was drawn twice. And this is what the graph looks like. Okay, the next example I'm going to do is r equals 6 over cosine of theta, or better yet, r equals 6 secant of theta. And if you notice, I'm going to put this in the calculator. I'm going to change my equation to 6 divided by cosine theta. And I'm going to hit the word graph. And look how it's drawing. It drew a vertical line, but notice where it's starting. It's starting at the x-axis, going up forever to positive infinity, and coming back from negative infinity. What does this look like in the table? Well, my table setup is 0 through 15 like it was before. And now I could copy down all these numbers and start plotting these points. Okay, I've completed this table using my graphing calculator. I'm now going to plot these points at 0 degrees. I'm going to go out to 6. 1, 2, 3, 4, 5, 6. At 15 degrees, I'm going to be at 6.2. At 30 degrees, I'm going to be at 6.9. At 45 degrees, I'm going to be at 8.5. 60 degrees, I'm going to be at 12. That's off the grid. 75 degrees, I'm going to be at 23.2. That's off the grid. 90 degrees, I'm going to be fine. That means I wouldn't draw a point at 90 degrees. But then I get to 105, and 100, which is negative 23.2, again, that would be off the grid. 120 is negative 12, that would be off the grid. But when I get to 135 degrees, I have to plot negative 8.5. So if I go this way, that would be, right this point here would be positive 8.5. I have to go negative 8.5, which is on the going the other way, and that would be the point right here. And then I would have 150 and 6.9. And then I would have 165, 6.2. And then I would have 180, which is right here, and negative 6 would be this way, right here. Back again. These other points I would do would be exactly, again, the points I did. And you notice it is this graph, the best I could do it with a free hand. It is a vertical line, again, drawn twice. On to the next example, r equals 4 plus 4 sine of theta, which is a little bit different than the one we've done before. Go to y equals, clear out of here, 4 plus 4 sine theta. And I could hit zoom 6 and zoom 5, but it's already set up for it. I'll just hit graph. And here we go. I still have the tracer on, and it draws it nice and slow. And I get a little bit different graph. It's not going to be a circle. This graph is called our cardioid. Right now it looks like an upside down heart. If I drew it a different way, put a little bit different formula in there, it would be it would be turned around. But we're going to graph these points. Again, I'm going to go to second window, and I'm going to do second graph, and I'm going to put all these points into that table, and then I'm going to graph these points. As you can see, I completed the table using the graphic calculator, and now I'm going to start plotting these points at 0 degrees. I'm going to go up 4. So I'm going to get my pen back. 1, 2, 3, 4. 15 degrees, I'm going to be at 5. 30 degrees, I'm going to be at 6. 45 degrees, I'm going to be at 6.8. 60 degrees, I'm going to be at 7.5. And then 7.9 at 75 degrees. And finally, I'm at 8 at 90 degrees. I'm going to pause the video and do the rest of the points. Okay, apply the rest of the points. As you see, when you get near the 240 to 300 mark, it's very hard to plot those points. Don't worry about getting them exact. You can see what the graph looks like, and then once you're done, you can just draw this graph to the best of your abilities. And this is called a cardioid. It's a different looking graph. Okay, my next example is r equals 5 cosine of 3 theta. It's a little bit different. I have a number in front of the theta, 3 theta. Let's see what happens when I put this in the calculator. Clear it out. 5 cosine 3 theta is my equation. And when I hit the graph, notice I still have my cursor on. It is drawing a flower. This is a 3-petal flower. Notice it's drawing it twice. We'll go over that in a minute. Now, when I want to do my table, notice my delta table is no longer up by 15s. They're up by 10s. So when I go to second window, I got to set this equal to 10. Not 15 like I had it before. And then when I go in here, I see all the values, 0, 10, 20, 30, 40 degrees, and I have all my R values, and this is what I'm going to use to complete the table. Okay, I completed my table by using my graphing calculator. I'm going to use all these values. I'm going to plot all these R's and thetas. Here's my table here, but for me to be able to do all this, I'm going to plot it on this grid below. Okay, so I can't really see both at the same time. But my first point is going to be 0, 5, and then 10, 4.3. So here's my grid. I'm going to do it in purple. So 0, angle, 5. 1, 2, 3, 4, 5. Notice this is a bigger grid than before. 10 is going to be at 4.3, so 10, 4.3. And then 20 is at 2.5, so here's 20. Here's 4.3. Now that's a little bit off. 4.3 is right around here. And then 2.5 is 1, 2, oh my goodness. Way off. Sorry about that. 4.3 is right here. Getting a little bit blurry looking at this grid. Okay, 2.5. 1, 2, 2.5. And then at 30 degrees, I'm at 0, which is the origin. And at 40 degrees, I'm at negative 2.5. So here's 40 degrees, so I have to go backwards, which is 220. So 1, 2, 2.5. 50 degrees are going to be at negative 4.3, which is right here. And then 60 degrees is at negative 5, which is right here. I'm going to pause the video and do the rest of the points. Okay, I plotted all the points very carefully after making my mistake from before. Sorry about that. And some of them are actually plotted twice, but obviously you can't see them. So when I'm done, I'm just drawing all of these, what I call hills. There's one here. There's one here. And finally, there's one here. It is a flower with 3 petals. And the reason why it has 3 petals, because of the 3 in front of the theta, and it's actually drawn twice. So 3 theta causes 3 petals. And this last graph that we're going to draw is r equals 5 sine theta. Very similar to what we did before, except now it's going to be y, or r equals 5 sine of 4 theta. Not 3 theta, 4. Maybe that makes a difference. I could just hit graph because I'm using the same window as before. And I get this graph. It is another flower graph, except now it has 8 petals. So we'll have to talk about why it's 8 petals and not 4 petals in a minute. Maybe it's a little jagged. Oh, not too bad, because I set my theta step on my calculator as 2, so it's drawing things pretty clearly. So how do I do this on the table? Well, if you notice, I changed my delta table to 7.5 for this table. So when I do this on the calculator, when I go to second window, I got to change this. Instead of delta table being 10, it's got to be 7.5. And then I'm going to do second graph. I see this whole table, and I'm going to put this in to this table when I pause the video. So as you see, as I completed this table, it's really similar to the same previous problem. A lot of 2.5s, 4.3s, 5s, and 0s in this table with negatives with them. So I'm going to take all these points and I'm going to graph them on this grid. The only thing I'm going to do a little bit different is I'm not going to space it in as 5s. I'm going to make each concentric circle, r is going to equal a half. So in other words, this is a half, 1, a half, 2, this is 2.5, 3, 3.5, 4, 4.5, and this is worth 5. Instead of going by 1 each circle, it's worth a half. So let's plot some of these points. I'm going to do it in orange. So my first point is 0, 0, which is the origin. And then I get 7.5 degrees and 2.5. So 7.5 degrees is right here, and 2.5. Then I get 15 degrees is 4.3, and 22.5 degrees, which is right here, is 5. And then 30 degrees is 4.3. And then 37.5 degrees, which is right here, is 2.5. And then 45 degrees is back at 0. And you can kind of see one petal being formed right here. I'm going to pause the video and do the rest of the petals. So as you can see, I drew the rest of the dots. I'm going to draw the petals. So this one kind of goes this way. And then this one. The best of my ability. On this thing, it's not so easy. Move this thing around. Here, something like this. I'm basically seeing 2 petals per quadrant. So this is a flower with 8 petals. That's because we had 4 theta. So I think the rule will be when I have sine or cosine of a number, let's call it n, so when n is even, I get 2 times n petals. Like 4 theta, I had 8 petals, and when n is odd, I get n petals, but it's a picture that is drawn twice. Okay, thank you very much for watching this video.